Hi, everyone. Welcome to today's online summit, Enterprise Hybrid Cloud 101. This event was organized by the hardworking folks at Virtualization and Cloud Review and Redmond Magazine, who have brought together some of the best independent experts on today's topic. Many thanks to our sponsor, Nutanix, for making this event possible. And thanks to you for joining us. I'm John K. Waters, Editor-in-Chief in the Converge 360 group of 1105 Media, and I'll be your moderator for the first of 3 information-packed sessions. But before we get started, a bit of housekeeping. Each of today's sessions is being recorded for later access. Keep an eye out for an email with a link to that recording. It'll be coming your way within the next few days. Each of today's sessions will be followed by a 5 to 10 minute Q&A. You could type your questions into the Q&A box at any time. Please feel free to add your questions as they occur to you throughout the summit. We'll do our very best to get to all of them. Our sponsor has been providing some extra resources that can be found on the right-hand side of your screen. Please take a moment to check those out. And at the end of this summit, you'll be asked to take a very short survey. Please take a moment to share your honest opinions. Our editors actually read every comment. I'm one of them, so I know it's true. Your opinions help to shape our future events. And last but not least, at the end of the third session, one lucky attendee will be receiving an Xbox Series X, the fastest, most powerful Xbox on the market, thanks to the Velocity architecture, which pairs a custom SSD with integrated software for faster, streamlined gameplay and massively reduced load times, pardon me. But you gotta be in it to win it, so stick with it. Now let's get started with the first session, Hybrid Cloud 101, Hybrid Pros, Cons, and Infrastructure Basics. For this session, we've called on Joey D'Antoni, Principal Consultant at Denny Cherry and Associates Consulting. With more than 2 decades of IT experience at Fortune 500 companies, as well as expert certifications from Microsoft and VMware, Joey is a well-known thought leader in cross-platform IT. He's worked extensively on database platforms and cloud technologies, and he has a special expertise in performance tuning, infrastructure, and disaster recovery. You're in for a great session. Take it away, Joey.
Thanks, John. Welcome, everyone. I'm glad you could be here, and I look forward to talking this session. I want to cover a lot of the basics of cloud infrastructure and when we talk about. And when we talk about hybrid cloud, a lot of this gets kind of muddled because I feel like almost every cloud deployment is a hybrid cloud deployment because all organizations deploy cloud in different ways, and it can be kind of messy, and not all systems move at once because that's just not the way these things go in terms of how cloud migrations happen. So a hybrid cloud can mean a lot of things. It can mean you have your email is running on Office 365 or Google Suite, but maybe you have some of your core business applications on servers running in a data center, or maybe you move some of your core systems that are customer facing into a public cloud like AWS or Azure, and you keep some of your backend systems in your office or in a local data center. So there are a number of approaches that different organizations take, and it tends to kind of come down to migration and pathways like that. The only customers who tend to be 100% in the cloud are organizations that are, generally speaking, less mature, so startup type organizations. However, some organizations do go all in. And other organizations will take the approach of having a private cloud with maybe burst capabilities into the cloud. And typically, when we think about private cloud, we think of something fairly formal and with automated infrastructure. Sometimes it can even be purchased from a cloud vendor like AWS or Azure, like Azure Stack or AWS Outpost, that let you effectively simulate the cloud infrastructure in an on-prem environment. The customers that tend to adopt those private cloud platforms tend to be very large enterprises. I think that's probably just because the infrastructure for that stuff is pretty expensive because you tend to pay a hardware vendor, the cloud vendor, and you pay an ongoing fee to the cloud vendor. So it's not necessarily the most economic way of doing things, but it does give you a little bit higher degree of control. And one kind of myth I want to put down while we're talking about cloud and stuff, I don't think cloud is inherently cheaper than any traditional on-prem solution. I know there's a lot of thoughts around the economics of it. Really, when you're paying for the cloud, it's probably going to cost the same, if not more. But what you're paying for is the flexibility. So to be able to have data center locations all over the world, to be able to allocate petabytes of storage in seconds, those are the things you're paying for in the cloud. And those are the real benefits of the cloud. Those are things that if you need storage on-prem, you need to work with your storage vendor, and you're going to need lead time. So those are the kind of places where you see advantages. But almost every customer we deal with has something in the cloud, and almost all of them have something somewhere else, whether it be a co-location or an on-prem data center. This is kind of the basics, but I always like to talk about it. The basics of cloud delivery models and how we consume cloud resources. This is kind of important to understand because it ties into, say, flexibility. So in a platform as a service model, this is things like database as a service and storage as a service. The cloud provider is going to provide the full cloud infrastructure, so network, servers, data, and virtualization, along with a software platform that includes operating systems, middleware, and the runtime. And this model is really meant to provide customers with the ability to test, deploy, and operate their own applications without the complexity of building on-site infrastructures. There are a number of platform as a service offerings. I say database as a service is a very common one. Web app or website as a service is another very common. These services are characterized by a few key things that I want you to have a good understanding of the differentiation between PaaS and IaaS. In PaaS, and this is generally speaking, this does not apply universally to all services, but it's mostly accurate across them. Your service is going to be inherently highly available. You don't have to worry about making the service highly available by creating replicas and stuff. The service will take care of that for you. The service will also typically be backed up for you. And this is a question you always want to ask about a PaaS services because they do have different backup models. But generally speaking, they are all backed up by the control point of the cloud. You may have some degree of control over that, like you might be able to affect timings or retention. But generally speaking, that's a concept that's going to apply across PaaS services. Also, the operating systems are going to be patched for you. This means you don't have to worry about doing that. And in infrastructure as a service model, basically, when we talk about infrastructure as a service, we're talking about VMs, storage, virtual networking, maybe even Kubernetes services, because you can really kind of consume that in an IaaS model. In most of those cases, you're responsible for the patching of the machines, you're responsible for backups, and you're responsible for high availability. And I say in most cases, there are plugins that the cloud vendors will sell you to do all those things, or you can buy some of them from a third party. For example, there are some newer Azure virtual machines running on the latest version of Windows that support automated patching. You kind of have to do some configuration to get there, but that is part of the deal. The main difference between these two is you're responsible for your own backup, high availability, and patching, generally speaking, in IaaS. And you have OS access. Typically in platform as a service, you're not going to have access to the OS. You'll have access to logs and things like that, but you're not going to be able to log secure shell or remote desktop into a machine and see what's going on there. And then finally, software as a service. And of these, this is the most abstracted. Software as a service, the most common example I always like to talk about is Office 365, which is Microsoft Exchange, SharePoint, and OneDrive kind of all merged into one, including the desktop tools. And speaking as somebody who's an Office 365 admin for our company, I have most of the options I would have if I had on-prem Exchange, but I don't have to worry about patching it. I don't know where my servers are. We just consume email, and I'm an email admin. So I can configure things, but I don't care about servers at all. The big difference I'd say with software as a service is, generally speaking, we have no concerns about building networking. We're only really concerned about users and security with software as a service. Even in platform as a service offerings, you generally are concerned with how your network traffic is going to get routed there. So that's something that we don't worry about with SaaS offerings. In some cases, your platform as a service offerings may be on the internet and they may be firewalled. In other cases, they may be on private networks. It really just depends on the service and the nature of the service as well. So I wanted to walk through the basics of infrastructure and the core components that you need, in my opinion, to have good understanding around to do these sorts of migrations, because we face a lot of challenges. The cloud evolves pretty quickly. That's one of the things you'll notice. I was helping a customer today with a database as a service solution, and things had moved on screens that I was really not confident about. So I wanted to go over the basics, and the fundamentals of this stuff doesn't really change too much. So those are all key things that are important. And the basics of the infrastructure are pipes, and there's a reason why I chose this photo. The network, especially in a hybrid cloud model where you're moving data between your office or between your users that are maybe remote, in the cloud becomes a much bigger concern then, and you need to think about how that network architecture takes place. And one of the things we can kind of easily do within a cloud environment is change our networking, because everything is virtual and everything is software defined, so it becomes much easier to build and destroy things. But to get those physical connections in place, and we'll talk about that in a second, is really kind of the first step you need to do towards building out your hybrid cloud model. And it's really important to get that right and get a good understanding of what that picture is going to look like. So like I mentioned, unless you're a startup, you'll probably have resources in on-premises and co-location data centers. If you're an organization of any size, cloud migrations rarely happen all at once. This can be slammed, but what tends to happen, and this is my next point, moving core resources usually involves some level of downtime. And through my career, most of the work I've done has revolved around databases and database workloads. And yes, our databases are responsible for most of this downtime, because databases have to be in sync. They respect principles of consistency and durability. So for that to happen, we have to get transactionally consistent copies, and it's really hard to make a database live in two places and be transactionally consistent. So we have to do special things, especially for those critical systems. There are tools that will help you do cloud migrations. Azure Migrate's an example. Zerto has a similar disaster recovery tool where you can effectively migrate using infrastructure-based solutions, and those work very well. But for your critical systems where you're concerned about losing those last few transactions, that's where you need to have really kid-glove handled migrations. And typically the way it works in most of the customers we've done migrations for is groups of applications that work together will move all at the same time. Of course, with critical applications being last to go. And sometimes you just have stuff that ends up staying. Like we have customers that have point of sale systems that run in stores that don't have great internet connectivity, so they're a little bit leery of just moving all of that infrastructure to the cloud. So keep that in mind. Most organizations are going to be hybrid, so understanding these principles and having a strategy around it is kind of important. So understanding cloud networking. I modified this slide after I wrote it, and that's why there's a step 0 here. Know your cloud and its regions. Kind of an obvious thing, but know what provider you're going with and understand where their regions are. Understand why you might want to choose the region you want to choose. The regions, especially on the Azure and GCP side, are kind of constantly changing as Microsoft and Google add regions. AWS is a little bit more stable because I think they're a little bit more mature. But all of these cloud vendors have lots of regions all over the world. There are various sites online or APIs you can call to see what your network latency is to those regions. Frequently, a lot of the locations are near each other. The Northern Virginia area is a very common one. AWS is a region in Northern Oregon. Microsoft has a region in Central Washington. I think both have regions around Chicago. This is typically because it's where the internet, the biggest amount of internet cables pass through, because cloud regions use a lot of bandwidth. So once you understand what cloud you're using and what region you're using, and what their networking structure kind of looks like to you, because that's going to be a key part of that, and we'll talk about that here in a bit. You want to get a VPN. You can just have a VPN connection to your cloud. For example, DCAC has one from our colo to Microsoft Azure, and it's a site-to-site VPN. So it's persisted, but we're pretty limited in the amount of bandwidth we have. I think we have like 100 megabytes or megabits per second. So it's not like a huge connection between us and Azure, and it just goes over the public internet. What you want to get, especially if you're going to be permanently hybrid or even for like a large-scale migration, is a direct connection to the cloud provider. And you'll have to work with a few different people on this. And this can be a little bit of a challenge, especially if you're in a colo environment, because typically what's going to happen is the colo is going to have like one connection to each cloud, and you'll get a split of it. But you'll need to work with an ISP and your cloud vendor on this. And it's called Direct Connect on AWS, ExpressRoute on Azure, and on Google Cloud, it's called Dedicated Interconnect. And all this is a direct connection from either your data center, your co-location provider, to a region in the cloud. So it'll be a direct connection. You pay based on the amount of bandwidth you use. So that's important to note. I know the Microsoft options go from not a whole lot, like I think 500 meg, all the way up to 100 gig. They stopped showing the prices past 10 gig. We've never had a customer buy any more than 10 gig, but I'm sure there are some that have needed it. But getting that connection in place makes everything else easy, because getting data back and forth is going to go a lot more quickly. Once your data is in the cloud, the latency within the cloud providers is pretty good, and we'll talk more about that here in a second. Understanding cloud networking is also kind of an important thing. So cloud networking can be very different from on-premises. The basics of virtual networks and subnets are all pretty much the same. We don't suddenly change IP calculations when we're in the cloud. But a lot of constructs are very different, whether it be firewalls, how load balancing works in the cloud. What I see a lot of organizations do, maybe they work with F5 or for their load balancers, and they work with FortiGate for their firewalls, and they'll recreate their entire networking stack on the cloud. That can be a little bit easy. Well, it's definitely easy because it's things you're familiar with. But it can definitely be more expensive and also be less efficient than simply refactoring your network to take advantage of some of the cloud-native solutions that are there. In some cases, maybe the network appliance you're using on-prem has some features that the cloud doesn't match, but it's worth evaluating. What a lot of organizations will do is, as they migrate, they'll migrate and replace everything, rebuild everything exactly like what they had. But the other part of that is they'll over time, they'll come back and look a few months later and start to switch things out. Networking is one of the places where you can save a lot of money too. Because things like load balancing tends to be a lot cheaper in cloud native solutions. So if you're using, an expensive appliance to do network load balancing, maybe take a look at what's available. But it's easier to reconfigure networking in the cloud because you don't have to rerun cable. Simple is better than complex. And what I mean by that is I like to use native solutions wherever I can because as you involve third parties in these network designs, figuring out the support model when you have problems is harder. Taking advantage of what the cloud gives you is really nice. The other thing you want to note is the cost associated with networking. Data egress, and you'll notice I have 3 exclamation points, and this is kind of an important thing to think about, especially in a hybrid cloud model where you probably are shuffling data back and forth. Any data that leaves your cloud, any data that leaves one cloud region and goes to another, in some cases, any data that leaves a virtual network in the cloud and goes to another virtual network, that data is all metered and you pay for it. This is something I run into more with my customers that are on AWS than Azure. Azure obviously still bills for that. But it comes up way more frequently with AWS. I think either they're better at charging for it or they charge more, and I fully understand why. The other part you want to understand is one other thing I want to mention on egress. I know at least on the Azure side, you can pay for on your express route, you can basically pay for unlimited downstream data. The cost difference is very, very significant. I think it's like 10x difference. Or you can deal with the metered data and kind of pay as you go, depending on how risk averse, and maybe you want to go pay as you go for a little while, and if you see you're using a lot, then pay for the unlimited. But understand that. The other part of that is to understand which network services are free and which have supplemental charges. And I do have 3 in quotation marks there. It's kind of funny. Like I mentioned, I think this is one of the places you can save a lot of money. For example, and I'm going to reference Azure, I know way more about Azure costing than I do AWS. In Azure, basic load balancers are free. So if you're load balancing between 2 nodes on a single virtual network, that load balancing solution is free. If you have to suddenly load balance between availability zones, which means 2 different physical data centers, that load balancer costs some money, not a tremendous amount, on the order of $100 a month or something like that. If you want to do global load balancing, that's going to cost more. Connecting networks is free, but public IP addresses are paid. So it's important to understand what the services cost. And one of the things that I think changes in your role as an IT professional when you start working with cloud more, and we're talking here specifically about networking, but it applies everywhere. You need to ensure that you have a basic understanding of the costing model of the services you're consuming. So you have to be a little bit of an economist, which is something you maybe didn't have to do when you were just consuming on-prem resources. You don't want to deploy something that's going to cost millions of dollars, just to get some network traffic back and forth. So understand your cost models. The third-party stuff on the networking side can really bite you. The first-party stuff is expensive. AWS is some very expensive app proxy solutions. But you really just want to understand what those costing models are and how they're going to price out. Because I wanted to talk about this specifically in networking because it is kind of a hidden cost that doesn't really show up until you start consuming. One of the things that's also kind of interesting about networking is you want to understand the limits of your cloud resources that you're using. So when you buy a VM or even a platform as a service solution, everything in a public cloud is going to have a quality of service associated with it, and you're never ever going to exceed that quality of service. So let's say you have you had all the money and you got that 100 gig connection into Azure. and you're pushing a big stream of data from some on-premises VMs into the cloud. If your VM in Azure only has 200 megabits of bandwidth associated with it, that large pipe that you're filling up with lots of network traffic is going to bottleneck at that VM that doesn't have that much bandwidth associated to it. And effectively, this is going to vary based on the cloud resources. They're defined. The providers will typically show you what the either exact bandwidth is, or they'll give you kind of a t-shirt model, like small, medium, extra large, large. And one of the places where cost comes in again, the more you spend, the more bandwidth you're going to have. Depending on what you're doing, you can take different approaches to this. One example is if you're loading a bunch of data into storage accounts, typically each storage account is bandwidth limited, so you can partition that data across multiple accounts. There are lots of techniques to this, and it very quickly gets kind of deep into architecture. But just always know you want to understand what the network bandwidth limitations of your cloud resources are. Once you're in the cloud, the networking is very good. The latency is basically about as low as you can get. The vendors have bought and built really, really nice networks, but you still have the bandwidth constraints. So if you're going from a small VM to a small VM, you're still limited to the amount of bandwidth that the VM has, and that doesn't change anything. The same is going to apply when we talk about storage in a few slides. Platform as a service offerings get a lot of buzz. They're really cool. They do a lot of cool things, but most of the time, where those platform as a service offerings really benefit is newer applications that you're building. Because if you have third-party vendor applications, it's less common that they support platform as a service offerings. The main reason is the platform as a service offerings aren't the same on every cloud. So if you're a vendor writing software, it's really hard to write something that's going to support, say, Azure SQL Database and Amazon RDS and that kind of thing. So the vendors, this leads us to lots of software that still runs in virtual machines. This is a Gartner number, but 80% of cloud deployments are on VMs. And VMs will also typically represent a great deal of your cloud spend, like probably 60 to 70%, because especially for larger workloads, some of those VMs can be very expensive. On both Amazon and Azure, you can get a 416 core VM that has nearly 12 terabytes of memory that will cost you something on the order of $95,000 a month, depending on what region you put it in. So yeah, VMs can be very expensive. One of the things, and this is as your organization matures, there are a lot of types of cloud VMs, and they change regularly. If you think about the number of CPU models, and frankly, Azure and Amazon have been in business almost 15 years now. I think Amazon has been in cloud business for 15 years. So if you're on an older type of VM, you may benefit significantly by just changing out your VM model to a newer CPU architecture that will better allow you to get better performance for the same price. We've had customers that have done that, and basically they were able to have their CPUs by doing so. Generally speaking, in the clouds, it's easy to change VM sizes. It typically will require a reboot, but that's really about all there is to that. So it is something you want to kind of stay on top of. And sometimes the cloud vendors in the portal will give you or console will give you advice on hey, you're using this older VM class. Other times you may have to pay attention to it yourself, but it's a nice little nugget I like to tell people, because it's something that's easy to do and both can save money and improve your overall system performance. Backups, and this is another place where I see a lot of hybrid solutions. The cloud is really, really good for backups. I think the kind of storage you use for backups is is more cost effective in the cloud. The object-based storage model, you tend to have automated tiering. Most of the cloud, both Amazon and Azure have archive storage that costs roughly a penny a gig a month. This is especially good if you're working in a regulated industry, where somebody's making, some government agency is making you keep backups for an extended period of time, and you really never use those backups. And there are a number of different approaches you can take to doing backup in the cloud. The cloud vendors typically have solutions, and you can run these from on-prem servers, so you can back up your on-prem servers into the cloud, or you can run them from your cloud servers. And having a backup strategy within your cloud is just as important as on premises. Those VMs can get ransomware too. As I mentioned earlier, as you start using platform as a service offerings, which is something that will typically happen as you become more mature in your cloud adoption, being able to understand what that backup strategy looks like is also really important. And understanding the options and security around your cloud backups. And this is something you want to talk to your backup vendor about, whether that be your cloud provider or a third-party vendor. With the common thread of ransomware attacks, and the pattern there is to go after and attack backups. So what you really ideally want is backups that are immutable and protected, and even if somebody gets admin, they can't delete them. Like most of the cloud storage solutions will have soft delete, which means even if somebody deletes something, it won't go away for a couple weeks, or something like that. There are additional layers of protection that the clouds don't always talk about. So really having a good understanding, backups are very important in terms of, even if you're just strictly on, it doesn't matter where your data lives, it's very important to have good backups and understanding how your backups work and understanding how your databases get backed up. That is one thing we run into a lot, is if you're using an infrastructure-based backup solution, it may do not the best job of backing up your databases, and you may want to go with a little more customized solution for those database backups as well. Storage performance is a challenge in the cloud. I say this, I work with lots of customers with really heavy workloads. The main customers who still keep workloads on-prem typically have really, really fast on-prem storage from vendors like Pure or Extreme.io from EMC. Those all flash solid state arrays with 32 or 64 gigabit fiber channel connections to the array and latency that is in the sub-millisecond range. Those are the kinds of workloads that are a real challenge to move into the cloud. It's really easy, or I don't want to say it's really easy. You can get very good storage performance in the cloud pretty easily. And by pretty good, I mean on the order of 5 to 10 milliseconds of latency, which for most workloads, that's perfectly all right. However, if you're looking for that sub-millisecond, I'm running a gambling site and I need to record every transaction very quickly, the cloud's going to be a challenge for you. The main issue being all the storage is remote, so the latencies tend to be a little bit higher just from the storage being remote. Also, you tend not to have the same amount of storage bandwidth that you would have in an on-prem world. So it's just a little bit of overhead. Everything is rate limited, so depending on the nature of your storage, you may have to strike multiple disks together to get the performance or volume you need. I think Azure has a fix for this coming soon, where you're going to be able to independently allocate IOPS and volume. It exists, but on a really expensive tier of storage that doesn't really have any additional benefits. And your storage costs can vary dramatically. Just to give you an example, I'll refer to Azure pricing. if you have the most common disk we use for database virtual machines is a P30 disk, and that's a premium SSD disk in Azure parlance. It will do 5,000 I/O operations per second, and it has 200 megabytes per second of bandwidth. That same disk, if I create it as an ultra disk with those same parameters, that premium SSD is going to cost about $135 a month. If I create that as an ultra disk, it's going to cost around $410 a month. If I want a 1 terabyte regular spinning hard disk, not going to give me the same performance characteristics, but the same amount of storage, that's going to cost me around $40 per month. But I can't really use that for any kind of I/O sensitive workload like a database. So storage costs can vary dramatically, and understand that and understanding storage will help you along with that. So cloud storage breaks down into a few different types, and I'll talk a little bit about cost as we're associating these. File storage, this is effectively a file share as a service. These can be NFS or CIF shares. And these tend to be more expensive than the basic object storage. So S3 and Azure Blob Storage, S3 being Amazon, are very cheap in terms of cost per terabyte. The file storage is usually about 2 times that. VM storage is going to vary on price depending on tier. We kind of just walked through that 40, 135, and 410 per terabyte example. And the cost of that's going to break down based on the performance characteristics of the disk you're choosing. Those are all pretty straightforward, and the 2 most common things you'll probably use are VM storage and file storage. There are a few different file storage options. Some of them are more expensive than others. And then there are queue storage, so you can have queues for messaging-based applications. These are less commonly used unless you're writing applications, and then you're using them. And it's important to understand the cost model and the performance for your storage type. They can vary somewhat dramatically, so this is really going to be what's going to drive your application performance. So that's something that's important to understand. Identity. So I kind of talked about how the first thing you should do before you do anything involved with making a hybrid cloud or putting anything into the public cloud is get a virtual private network in place. That is still my belief. The second thing you should do, if you are like 90% of cloud users and you use Windows Active Directory for authentication, you should have a domain control in your cloud to handle authentications that take place there. And honestly, you should probably have 2 of them. In Active Directory sites and services, you should create a site for your cloud region. That's to handle applications that are authenticating in a traditional manner on-prem against using Kerberos, just to handle normal applications that may be there. However, the other part of this is you need to understand identity management within your cloud. When you typically first get started and you're in a hybrid model and you don't have a whole lot of resources in the cloud, this is typically just going to be your admins that are going to need access and be defined. But as you mature, or maybe an example is if you use Office 365, you're going to have to sync your on-prem Active Directory with Cloud Active Directory, and you'll have a lot more users there. The other aspect of this is cloud services can also have identities. So just like you would have a service account in a Windows environment, you would have an identity for a cloud application. And typically you're going to register that application, then you give the application just the permissions it needs. I was actually working with this right before we got on this call. And this will be super helpful to let you do more automation and drive applications. It's something that a lot of modern applications do. I will say this is a place where I have a strong preference for Microsoft Azure. And caveat, I'm a Microsoft MVP and they give me cloud credits, so full disclosure there. I really like the way they do identity management. It's very easy to work with and has been intuitive to me. So I've been pretty happy about that. And I think it's a pretty good solution, and it's a little bit easier. The fact that it comes from regular Active Directory, it makes for an easier transition. But understanding that identity component, making sure you have a set of single sign-ons so that everybody's doing the same things in the cloud, those are all really important. And while we're here, because I have to mention MFA every time I give a talk on any of this stuff, make sure you have MFA enabled. Actually, the way I log into Azure now, into our tenant, is by using a YubiKey. I don't even use my password. So yeah, for sure, make sure you have MFA. So some 10 tips for hybrid cloud. Before we have a summary and wrap up and take some questions, I wanted to highlight everything that I think you need to learn and understand, and hope you gleaned out of this presentation. Build and design your network before anything else. And if you're doing this at any sort of scale, get a direct connection. The one thing that really stinks about getting the direct connection is if you're doing a migration, typically you're going to have to sign an agreement with the ISP that's going to be a year or more. And you kind of can't, so if you're doing a 6-month migration plan, you're still stuck with 6 additional months. That is just kind of the cost of doing business there. Tip 2, make your cloud network cloud native. And what this means is look at using native solutions where you can. Unless you have a specific need to use a third-party solution in at least the networking aspects of your cloud, I really like to stick to the basics that the cloud provider offers. It's just a cleaner way of doing things. It reduces troubleshooting hassle. When network routes stop, you have one vendor to call. Understand your bandwidth limits between services. Those exist not just at your core network, but at different types of services, and even platform as a service offerings will have bandwidth limits. Storage will likely be your biggest performance challenge. It's just not as fast as the fastest stuff you can buy on-prem. There are some places where you can get ephemeral storage that's local to the VMs and is NVMe storage. That's really cool. It delivers really high performance. The issue is when your VM is deallocated, the data on your storage goes away. So you need to have, if you're taking advantage of those, and there are major cloud services that do take advantage of those types of VMs for their performance, you do have to have some coordination in place so that you don't lose that data. That's kind of really a different presentation. And then understanding the types of storage that are best needed for your workload. This is more a cost management thing. You don't necessarily need to throw everything on the fastest SSD, and that can be a key cost. Next slide. I couldn't get PowerPoint to do 5 through 10. I struggled. There are lots of VM types. Choose wisely. This is a place where you want to look. Typically, you want to go, especially if you're deploying new stuff, you want to go to the latest VM families. And then sizing your VM should be roughly the same as they were on-prem or in your hybrid environment. If you screwed up your VM choice, it's very easy to change. This is the first place I introduced this bullet, but this is a very important one. Reserving your VM resources will save you lots and lots of money. This is probably the biggest cost saving things you can do, besides just flat out turning stuff off. If you know you're going to have resources in the cloud for 1 or 3 years, you can tell Amazon or Microsoft or Google that you're going to have that stuff for that period of time, and they will give you a 50 to 70% discount. So that's a big amount of savings. Typically, you can shift those reservations around. Kind of a different talk, but I did want to put that in because it is really important. Backups still matter in the cloud. The cloud isn't magic. You don't automatically have backups unless your service does it for you. But typically, especially if you're building VMs, you don't have you don't have backups associated with that. And then finally, identity management is important for both native cloud and hybrid. So keep in mind that you need to have, for hybrid, you probably need to have domain controllers in both places or authentication servers in both places. And you also need to understand the native authentication for the cloud. Finally, in summary, hybrid cloud is where most organizations live. Building this core infrastructure is key to your success. Getting the networking well done and orchestrated will really help things flow. You can go really deep on cloud networking and do some pretty amazing architectures and have really great security. It's not that hard to do. Choosing your components like VMs and storage types carefully will be a big benefit. Backups are always really important. And then finally, don't forget about identity and where you're going to authenticate, because that's going to be core to a lot of your applications. With that, John, do we have any questions?
We do. Thanks, Joey. I want to remind attendees that there's still plenty of time to type your questions into the Q&A box. You can do it at any time. We'll do our best to get to all of them. Let me see here. Sorry, I got the live view in front of me. Okay, let's start with this one. Joey, how would you recommend getting started with identity management in the cloud? You talked a lot about it and put a lot of emphasis on it. How would you recommend getting started?
Yeah, so this is kind of really going to depend on your cloud. So if you're in Azure, it's pretty straightforward. You're probably going to sync your on-prem Active Directory with Azure Active Directory and start using Azure Active Directory. The other aspect of that is you're probably going to want to put a domain controller or more in the cloud. On the Amazon and Google side, you want to figure out which identity provider you're going to use for those clouds. You're still going to want to do the domain controller things because you're going to have applications that are going to be dependent on a domain controller authenticating a user and issuing a Kerberos ticket. But then you're going to want to look to see what authentication provider you want to use. And there are a number that you can use there, including Azure. But a lot of our customers like to use Okta with AWS. And that will control your authentication and identity management within that control plane.
Awesome, thank you. Okay, here's one. What are some of the approaches to cloud backup for VMs?
So there are a number. And one thing I always like to talk about is understand the nature of your recovery and your data and how you can recover. And in some cases, this may mean not taking a backup. I know I just harp on you for taking backups. But for example, one of the things we do with our customers that have database servers in the cloud, we typically back up their databases into cloud storage. And then we don't back up the servers. The reason why is we can deploy a new server from a template image with the database engine already installed faster than we can restore that entire server. And then we can start restoring databases immediately. And it's a more cost-effective way of doing things, and it's a better performance way of doing things. That said, the cloud services do tend to provide native backups, or you can just back up your VMs. They may or may not be aware of any application-specific backups like databases. Also, almost every third-party backup provider you've heard of has a solution that will work on cloud VMs as well.
Okay. How can I tell how much bandwidth my cloud VM has? Good
question. Typically, that's going to be just refer to documentation that the cloud vendors are going to provide. And those charts are really important because a lot of the things we talked about choosing VMs based on CPU families and things like that are going to be in those same charts. In some cases, they'll tell you an exact amount of bandwidth, and sometimes they'll group it together. A lot of times what will happen is even though you're kind of guaranteed the full amount of bandwidth that is allocated to your VM, as you approach that limit, you will notice some throttling and some bouncing off the bandwidth limit. If you're at the limit of thinking what you're going to need, you may need a little bit more, so you may need to go up to the next size.
Very interesting. Okay, maybe we've got time for one more question here. What are the costs associated with a direct VPN connection to your provider?
They're a lot. So you have to pay the cloud vendor. So you pay the cloud vendor, you pay, and then you pay the provider, the telecom provider. So in the U.S., this might be Verizon or AT&T. You'll pay them. You'll pay Microsoft or Amazon. The other aspect of this is if you don't own your data center and you're working with a colo facility, you may have to pay them as well. In that scenario, you may not have to pay. You may not have to pay your telco. They may lease the line to you that they're already paying for, but it will typically be more expensive in that scenario because they're wanting to collect some overhead on that as well. It's not cheap to get that direct connection. So if you can get it and maybe you go out of hybrid and go full public cloud, it is a cost savings. The other thing to keep in mind is as you move more workloads into the cloud, you can probably reduce the size of that connection.
Thank you, Joe. Looks like that's all the questions we have time for this session. We are going to take a short break, but we'll be back at the top of the hour for our second session, Hybrid Cloud 102, Hybrid Cloud Security, Backup, and Recovery, led by Brian Posey and moderated by David Rammel, who leads the must-read reporting in Virtualization and Cloud Review. Many thanks to Joey D'Antoni for a great session and to our sponsor, Nutanix, for making it possible. Now would be a great time to check out those extra resources on your console provided by our sponsor. The third session will start at the top of the hour, as they said, and we will the second session, I should say, and for the third session, he tried to say we will be giving away that sweet Xbox Series X to one lucky attendee, but you must be present to win, so stay tuned. Back in a few.
Okay, welcome back, everyone. Thank you for being here. And, of course, a big thanks to our sponsor, Nutanix, for underwriting the summit and allowing us to bring you this great content. I'm David Rammel, editor of Virtualization and Cloud Review, here to moderate the second session of our summit called Hybrid Cloud 102, Best Practices for Hybrid Cloud Security / Backup / Recovery. Our speaker for this session is Brian Posey, a freelance technology author, 21-time Microsoft MVP, and a commercial astronaut candidate. Throughout his career, Brian has written or contributed to dozens of IT books and created numerous full-length video training courses and published thousands of blog posts on a huge variety of IT and space-related topics. Many of those blog posts can be found in his Posey's Tips and Tricks column or in his new Posey's Moonshot column. Brian, it's great to have you here. Please take it away.
Yeah, thank you so much, David, and hello, greetings, and welcome, everybody. So today we're going to be talking all about hybrid cloud and best practices for security and backup and recovery. Now, before I really get too far into this, there's two things that I need to quickly talk about. One, I just want to quickly mention that I'm in kind of an unusual situation right now, so there's the potential for a lot of background noise or possibly notifications on my phone that you may hear, and unfortunately there's nothing I can do about that, but I just wanted to give you a heads up that that is a possibility. The other thing that I wanted to talk about is why in the world we're lumping together security and backup recovery with regard to hybrid cloud. I mean, those things seem completely removed from each other, and in some ways it seems kind of odd to talk about them altogether. But if you really stop and think about it, it's all about data protection. Backup falls under the data protection umbrella, and security does too. I mean, when you're implementing security in your hybrid cloud environment, what you're really doing is trying to protect your data. So everything falls under that data protection umbrella, and that's why we're discussing all of this from the same standpoint and in the same event. So let's talk a little bit about requirements here. So security, what it all really boils down to, and I'm greatly oversimplifying here, but what it really boils down to is keeping the bad actors away from your data. And yes, I know there are other things. You want to keep the bad actors away from your infrastructure. You certainly don't want them sabotaging things. But really, at the end of the day, if you've protected your data and kept the bad guys out, you've done a good job. The other thing that security is all about is keeping legitimate users away from things that they don't need access to, because you never know when a user is going to become disgruntled and try to sabotage something, maybe go in and start deleting data or stealing data to take to a competitor. Or maybe a user is completely innocent, but they just click on something that they shouldn't and unleash a ransomware attack. The bottom line behind that is that that ransomware attack or that disgruntled user can't access and manipulate anything that they don't have rights to. So security is all about protecting your data against legitimate users as well, wherever possible. And of course, especially in some environments, it's all about keeping the auditors and the regulators happy. Now, what about backups? Well, backups are meant to be the last line of defense, and as I mentioned, they also fall under the data protection umbrella. So in other words, security is about protecting your data, and then backups are kind of the last line of defense. If your security fails and something bad does happen to your data, then backups is, of course, how you would get that data back. Backups, even today, represent your best possible chance for recovering from a ransomware attack, for example. Now, obviously, the two aren't completely intertwined. There are plenty of situations in which the two are unrelated to one another. For example, you may have to restore a backup following a data loss event that has absolutely nothing to do with security. I know myself, I've accidentally deleted files on occasion and had to restore those files from backup. And that had nothing to do with somebody breaking into my network or a disgruntled user or anything like that. I just made a boneheaded move, and backups were how I recovered from that. I think that probably happens to most of us at one time or another. The same thing happens with security. Not every security incident warrants restoring a backup. Maybe you have a minor security incident and no data is ultimately affected. And in a situation like that, certainly there's no reason to restore a backup. You really don't want to restore a backup if you don't have to, as a matter of fact. And then, of course, there's another way of looking at the two together in that security can pertain to your backups. It's extremely important, in fact, to protect your backups against security incidents, because many ransomware attacks will specifically target the backups. Remember, the bad actors know that your backups represent your best chance of recovering and not paying the ransom. So they want to take your backups out of the equation by disabling those backups or destroying those backups or doing whatever they can to them. Now, certainly not every type of ransomware out there will attack a backup, but it is something that we're seeing more and more often. So it's extremely important while you're thinking about security and backup and recovery to just stop and think about what you might be doing or could do better with regard to protecting your backup from a security incident. So the bottom line behind all of this is that rather than talking about security and backup and recovery separately, it really makes a lot of sense to take a holistic approach and think about them as all part of the same data protection umbrella and look at those as pieces of a more comprehensive solution. So let's talk about best practices. The vast majority of the best practices that I'm going to be covering in this presentation come from the website that I've linked right here on the slide. I've thrown in a few of my own, but one thing that I do want to clarify before I get into this is that even though most of the best practices came from this particular website, I only use that as a starting point. I copied their list of best practices, but the interpretation of those best practices are purely my own. I didn't take the time to read their interpretation. I just came up with my own interpretation of those points. But with regard to best practices, one of the best practices, I didn't even really plan on talking about this, but this morning, out of just an unexpected chain of events, I ended up running into the guy who gave me, I don't want to say my first IT job, but my first real IT job. Maybe that's a good way of describing it. And this was more than 30 years ago. Hadn't seen the guy in forever. He's somebody that I have a tremendous amount of respect for, and he may even be listening right now. So Ed, if you're on here, thank you. But anyway, I got to talking to him for just a few minutes, and it really made me realize just how much things have changed in that length of time. And as I thought about it more and more, I started thinking the security standards that were commonplace back then, and I know we're talking about a long, long time ago, but the security standards that were commonplace back then are absolutely absurd by today's standards. Let me give you an example. When I got hired with that particular company, and I don't want to name names, but this was a Fortune 500 company, so it was a really large organization. And when I got hired by them, I was an 18-year-old kid. And I walked in on day one. I mean, they didn't know me from anybody other than just the fact I'd gone through a few interviews. Day one, I had full administrative access to all of this company's systems as an 18-year-old kid and access to everything. I mean, can you imagine that by today's standards? The point is that security standards evolve over time. Best practices evolve, sometimes drastically, as is in the case of what I just explained. So the reason why I tell you that is that even though I'm giving you the best practices as they are for today, these aren't going to be the best practices forever. Best practices change over time, and it's really, really important to periodically revisit those best practices and just make sure that you're staying up to date with them. So with that said, let's go ahead and get into the best practices. So the very first one, and this is something that really applies specifically to hybrid cloud environments, is to address interoperability issues. Now, I know it's really easy to say, okay, everything's working great, there are no interoperability issues, but hear me out on this one. If you think about the early days of Microsoft 365, I believe it was called Office 365 back then, things were vastly different than they are today. Because in the early days, Microsoft was encouraging organizations to adopt Microsoft Office 365 and to migrate their on-premises environment to the cloud. Not much different from now. The thing that was different, however, is that back then, Microsoft 365 was really, really immature, and a migration was unbelievably difficult to pull off. The documentation just wasn't there. I mean, maybe it was. You could find pieces of it scattered throughout the internet, but there was certainly no comprehensive guide that you could follow that would get you through the migration process. And so one year at Microsoft's TechEd conference, they came out and they were like, okay, we're simplifying the process. And that point got thunderous applause because everybody knew how difficult it was. And then they said, we've made it so that you can complete a full migration in, I think it was 6 steps. It might have been 5, it might have been 8. The number doesn't matter. The point is that they had taken this really, really complex process and narrowed it down to just a few steps. But unfortunately, the devil was in the details because every one of those steps had numerous sub-steps, and maybe it was documented a little bit better than it had been before, but it was still really, really difficult to get through. And part of that difficulty was because on-premises environments and the Microsoft Cloud just really didn't line up all that well. So there was a lot of things that you had to do to kind of make things fit into the cloud environment. It wasn't super graceful, but it worked. And, you know, I'm not just picking on Microsoft here. There are plenty of other cloud vendors that I've seen over the years where you had to, I think the term that was used was shimming. You had to shim an application that was used on premises to make it work in the cloud. And this holds true whether you're using a cloud-based virtual machine or a SaaS application or whatever. The point is that the early days of the cloud, a lot of times you had to do a lot of manipulation just to get something to work in the cloud. Now, what kind of manipulation? Maybe it involved installing a supplementary software tool that would allow things to work together. Maybe it involved turning off a security setting so that something would work in an environment where it wasn't really intended to be used. There were all kinds of fixes that were put into place to make things work. So the reason why I bring that up is because addressing interoperability issues is one of the very first best practices with regard to hybrid cloud. It's important to go back and take a look at, especially your long-standing cloud workloads, things that you've had up in the cloud for 8, 10, 12 years, and to just take a look at that and take a look at how they've been deployed and look at all of your settings and see if there's anything that maybe could be done a little bit better, see if shortcuts were taken when that application was first deployed or if security settings had been disabled just to make it work. Because now everything's had time to mature. We live in a cloud-first world, and so all of those shortcuts that maybe had to be taken 10 or 15 years ago don't matter anymore, but yet a lot of that is still in place. So from a security perspective, that's one of the very first things that I would recommend doing, is just looking at your long-standing cloud applications and how they're set up and checking to see if the security settings and any backend infrastructure you may have put in place is really necessary today. Because if you can eliminate some things and re-enable security settings, not only do you make the environment more secure, you could potentially, in the process, improve performance, and you may even manage to bring down costs a little bit. So those are all good things. So what else we got? The next one is to enable security automation and real-time visibility. And this one is really important because there's an old saying that you can't secure anything that you can't monitor. So in other words, you have to be able to see it in order to be able to tell if it's secure or not. Sounds really simple, but it's important. Now, when it comes to security automation, the idea is that it's a really good idea to put automated tools in place that will detect security events and then take automated action and do whatever happens to be appropriate in that particular situation. This is one of those things that is really important, but you also have to kind of be careful with it. So why is it important? Well, think about your network, whatever that may be. You've probably, even on a super small network, you've probably got thousands of events that are logged every single day. And most of those events are meaningless, but every once in a while there may be one that is really worth paying attention to. The point is that almost no organization has somebody on staff that will sit down and manually review all of those events. There's just too many of them. It's super time consuming. And even if you do have somebody who is solely dedicated to reviewing security events as they occur, that might not be a super effective process. Because think about it this way. Imagine for a moment that an attacker managed to do something to your network at 10 a.m., and it was something low level that kind of goes unnoticed. It could be anything, but just not something super catastrophic. So at 5 o'clock, you've got somebody who goes in and reviews all of the event logs for the day. Well, at that point, it's been 7 hours since that particular incident occurred. And you can imagine what kind of damage an attacker could potentially do in 7 hours' time. So even if you're reviewing your event logs every single day, that's probably not going to be enough. You need an automated tool that can catch these things in real time and respond accordingly. Now, as I said a moment ago, you do have to be careful with that. So there are a few things that I would recommend having caution about. First of all, security automation should never, ever, ever be a substitute for security expertise, because automation will only get you so far. An automated security engine might initially respond to an incident, but ultimately there's probably going to be somebody on staff who's going to have to make some decisions about the incident. So you need to have somebody who's got a good working knowledge of security, rather than just depending purely on an automated security product. Another thing to consider is that that security should never be treated as set it and forget it. So what do I mean by set it and forget it? Well, what I'm really talking about here is one of those situations where somebody with maybe a minimal knowledge of IT security finds an article like some of the ones that I've written or some of the ones that others have written that has, follow these 15 security best practices right now. So they go and they download that and they implement those 15 best practices. And certainly things are more secure after having done that, but that was never intended to be a comprehensive list of things to be done to secure an environment, because every environment is different. But also, as I said at the very beginning of the presentation, best practices evolve over time, and sometimes those evolving best practices change radically over time. So you don't want to be put in a situation where an administrator goes in, they set up security, and then they never touch it again, because even if they got everything absolutely perfect, best practices change over time. So what's perfect today isn't necessarily going to be perfect tomorrow. Let's see what else we got. Another point that's worth considering with regard to security automation, especially in a hybrid cloud environment, is that workloads are highly dynamic. New workloads are created all the time. Workloads are deprovisioned, and even more commonly, workloads get moved across environments. You may have a workload that's running in AWS today, and it might be in Azure tomorrow because of changing rates with regard to pricing or something like that, or maybe you move that workload back on premises or from the on-premises environment up to the cloud. Workload mobility is a real thing and will be for the foreseeable future. So whatever security product you're using to monitor your environment, it has to be dynamic enough that it can detect when a workload has been moved and continue to monitor that workload. setting that thing back up so that it can monitor the workload in its new location shouldn't even be an issue. So another best practice is to focus heavily on security concerns. I saw an article a while back, and I really, really wish that I could remember who wrote it or where I read it so that I could give proper credit. But this particular article asked a bunch of security professionals, what is the one thing that you really focus on? What is it that bothers you? What question do you constantly ask yourself? And the overwhelming number of people that answered that particular poll said that the number one question that they always think about is, what have I missed? What is it in my environment that I could be doing better or that I've completely overlooked and have this big gaping security hole that I just don't even know about? And I think that's fair. That's a very good response to that question. But at the same time, there's another answer that I think that if the respondents were to be 100% honest with themselves, would probably either be just as prevalent as the answer that was given, or maybe even a little more so, or possibly just a little less so. And that question is, what gaps exist that I do know about? Because pretty much everybody that I can think of off the top of my head who has ever done network security knows that they only have so much security budget to work with. And certainly you want to spend that security budget as wisely as you possibly can and get the best security for your budget dollar. But the thing is, there's rarely enough of a budget to do absolutely everything. So typically there will be something that has to be left undone. Now, I'm not talking about a huge gaping security hole. Hopefully most IT pros are more responsible than to allow something like that to remain. But I think most of us, if we were to really be honest with ourselves, we could think of at least one thing on our network security-wise that could be done better. So that's where I would recommend focusing future security efforts, is think about, okay, I've done all of this work to secure my network. What is it that could be better than it is now? And that's a great place to start with your security efforts. And the reason why I say this is because it's always going to be cheaper and easier to address those types of things now before an incident has occurred than to try to take care of it once an incident has already happened. So addressing longstanding security concerns is definitely something to consider. Sorry, having a little bit of an issue with the slides here, but I think I got it back on track. So another best practice is to exercise the principle of least privilege. Now, the idea behind least privilege, that's something that IT pros talk about until they're blue in the face, myself included. I couldn't even tell you how many of these presentations, and for whatever reason, the concept of least privilege access always seems to come up. And I think the reason for that is that it's something that's really, really important. So least privilege access, for anybody who's not familiar with the term, is the idea that a user shouldn't have access to anything more than the bare minimum that they need in order to get their job done. And there's a few different reasons for that. The main reason goes back to what I was talking about at the very beginning of the presentation, that simply put, a user can't sabotage or damage a resource that they can't even access. Because imagine for a moment that a user is working along and they open an email and that email has a malicious link in it. And this user doesn't know any better. They click on that malicious link and bam, they get hit by an automated ransomware infection. Well, that ransomware infection is probably going to attack the user's PC that they're working from. And then it's going to go out, depending on the ransomware variant, and see what else it can find to attack. It might attack map network drives. Maybe it's designed to look for and attack certain SaaS applications, or who knows what else. I've even heard of some of these infections attacking network printers. The point is this ransomware infection is going to go out and scour the network for any resources that it can attack. Now, if you're exercising the principle of least user access, you're going to limit the blast radius. You're going to limit the amount of damage that this ransomware can do. I mean, yes, the ransomware is still going to do damage at that point because anything that user had access to is potentially going to be compromised. All the ransomware has to do is find it. But if there's a folder or an application or some other resource that the user just doesn't have rights to, Well, the ransomware is not going to be able to touch that because it's operating under the same security context as the user who launched the ransomware. So the concept of least privilege access is super, super important with regard to keeping your environment secure. And as I mentioned earlier, it also helps with a disgruntled user who wants to go in and delete everything or steal data and sell it to your competition or something like that. So give users the bare minimum amount of access that they need in order to do their jobs. That's what least privilege access is all about. Now, the reason why I bring this up is because in nearly every discussion of least privilege access, it focuses on end users, just as I just did a second ago. But the concept of least privilege access doesn't have to apply exclusively to end users. It can also apply to endpoints. I'm talking about things like the PCs that users are working on, IoT devices, even some of the servers on your network, because not every server on your network has to be able to talk to every other resource on your network. You can actually go in and limit it so that one server can only talk to a certain other server. And these can be physical or virtual machines or whatever. It doesn't really matter. The point is that no device should have access to communicate with another device that there's not a direct business need for it to communicate with. Even if you're working in a purely Active Directory environment, every device that's joined to the Active Directory has an account, and it is possible to apply access control lists to the devices. So take a look at things like your endpoint devices, IoT devices, cloud-based tenant accounts, applications, even service accounts, and make sure that they only have access to the specific things that they need access to in order to do whatever it is that they're supposed to do. Now, one thing that I would caution you on with regard to role-based access control is that it's important. It's undeniably important. But at the same time, I have seen role-based access control give people a false sense of security before. Because you have to remember, role-based access control by itself doesn't do anything to keep the bad actors out of your network. The only thing that it does is it limits the amount of damage that can be done if somebody does make it in. So role-based access control is far from being a comprehensive security fix, but it's really, really important with regard to limiting the damage that can occur following a security incident. So another best practice is to enable regular audits of your systems. Now, certainly, if you work in a regulated industry, then this takes on a meaning all its own. Organizations that fall into a regulated industry are almost always subject to regular IT audits. And those audits happen in a very regulated and regimented way that are specific to whatever regulation that industry happens to fall into. That's not exactly what I'm talking about on this slide. What I'm primarily trying to address is organizations that are not in a regulated industry. And, I get it. The idea of an IT audit sounds awful. I can't speak for anyone else, but I know me personally, I don't want some busybody coming into my network, poking around, and then telling me all of the things that I've done wrong security-wise. I mean, sure, it's important to know what you've done wrong security-wise, but if you really stop and think about it, security is a trade-off. I've got a friend who always said that if you want to keep your data really, really secure, lock it up in a safe and drop the safe into the deepest part of the ocean. Nobody's going to get to your data. But of course, the problem with that is that the data is completely inaccessible to the people who need it. So security is a trade-off between keeping the data safe from the bad actors, but making it so that your users can use that data on an as-needed basis. So there's such a thing as having too much security, where the security actually becomes intrusive and things like that. So if you just hire an auditing firm, they may not really know the nature of your business and probably make all kinds of recommendations for things that might theoretically make your data a bit more secure, but they're going to make your users' lives a lot harder. So you've got to strike that balance between usability and security. And a really hardcore IT audit is probably not going to be in the best interest of a small business. Now, having said that, that doesn't mean that an audit's not important. It just means that there are probably better ways of going about it. So there are a few different things that you can do if you want to audit your IT security, but you don't want to subject yourself to an external auditing team. One possibility is to go out on the internet and search for IT audit checklist or something like that. I can't really give you the right or the exact term because I haven't done it recently, But there are websites out there that will give you a checklist of things that you should look for if you're doing a self-audit of your IT environment. As a matter of fact, PCI, the PCI regulations, that's the payment card industry regulations that apply to any organization that accepts credit card payments. They allow really small businesses to do a self-audit. And there are checklists out there that are specifically designed for PCI. Now, these checklists might not apply specifically to your environment, but they can be a good starting point. Another possibility is to use an automated tool to go in and audit your environment, because there are tools out there that can just go in and search for security deficiencies and generate a report. So whatever you're doing, the important thing to do is to make sure that you're actually doing it and that you're doing it on a regular basis. And my advice would be to make sure that you formally schedule these security audits to happen, because otherwise it's way too easy to either forget about them or to just say, we'll do it tomorrow, and it never really gets done, or it's done super inconsistently or something like that. Because when it comes to something as important as security and ever-evolving best practices and ever-changing attack vectors, it's really important to stay on top of it. Okay, so the next point is to make sure that you're securing all of your endpoints. Now, this one admittedly is a really, really tall order, but it's important nonetheless. I've always said that I consider endpoints to be probably the second biggest vulnerability in most organizations. The first and largest vulnerability, being the end users themselves. Because, if someone receives a malicious link in an email or sees a malicious link on a web page and they click on it, ultimately that comes down to the user. It wasn't the machine's fault, but rather the end user's fault. So I've always considered the user to be the biggest vulnerability, but their machine to be the second biggest vulnerability. And this is especially true now with so many people working remotely from personally owned machines. You don't know how those machines are configured, particularly if they're outside of the organization's direct control. So it's really, really important to use something like Microsoft Intune or a competing product, and just do some basic health checks on those machines before you allow them to access your sensitive resources, just to make sure that they're not infested with viruses or running jailbroken operating systems or things like that. Because maintaining endpoint security is a really important part of keeping your data secure, and that applies whether that data resides on premises or in the cloud or some combination of the two. Another best practice is to use a really comprehensive monitoring system. And this goes back to what I was talking about earlier, that you can't secure what you can't monitor. Because if you have an area of your network that's just a black box, information goes in, information goes out, you can't really see what's going on, it's really, really hard to assess that from a security standpoint. So you need a good monitoring tool that can see all the dark corners of your network. And there are some really good third-party tools out there that can do it. Now, with regard to tool selection, I'm certainly not here to recommend a particular vendor or anything like that. But a couple of things that I would recommend keeping in mind is to try to look for a single tool that can monitor both your on-premises and your cloud environments. And the reason why I say that is simply because of what I was saying earlier about dynamic workloads that tend to move around from place to place. And the other thing is it kind of goes back to an age-old argument that's existed in IT for as long as I can remember, and probably a long time before I ever got into IT. And that argument is it better to use one monolithic comprehensive solution, or is it better to get a lot of piecemeal solutions that are all best of breed at what they do? And I think you could make a very legitimate case for either one. But when it comes to something like monitoring your hybrid environment, I tend to lean heavily towards using a single tool rather than using a number of best-of-breed tools, simply because if you're using a collection of tools rather than a single tool, it's very easy to have an area that you miss in the monitoring process. Each one of those best-of-breed tools is going to focus on a specific area, and you may leave a particular area of your network unmonitored. Not to mention that every one of those tools is going to have its own reporting engine and its own management console, and it's just easier to use a single tool that can look over everything. But if you are going to use a single tool, then my big word of caution would be to make sure that that tool is extensible. Because as we all know, in the world of IT, things change rapidly. The applications that you're running today aren't going to be the same applications that you're running 6 months to a year from now. Sure, some will be the same, but there's going to be some new ones. And you've got to make sure that this tool, whatever it happens to be, is going to be able to keep up with those changes that occur over time. Another thing that's really important is to make sure that the tool gives you the ability to suppress certain types of alerts. There was an automated tool that I used quite a few years back. I'm not going to name the name of it, but I guarantee it's something that most of you have heard of. I decided to put this particular tool on my own personal network as a way of keeping track of security incidents and taking automated corrective action and just notifying me of what was going on. It seemed like a good idea at the time. The problem that I ran into is that there were certain types of events, and I'm trying to be careful with what I say here, but there were certain types of events that were normal for my network, but that this tool was interpreting as a potential security incident. So it was generating a massive number of event log entries. And the problem was that if there had been a legitimate security problem, it would have completely disappeared in this massive event log. So that's why it's so important to be able to suppress certain types of events, because you don't want to end up in a situation where you're getting a huge number of noise alerts that are completely meaningless, and there's so many of those that the important stuff goes unnoticed. Another best practice, and this is a big one, is to keep your processes uniform across the cloud. And I know this is a really difficult one to do because every cloud provider has their own way of doing things. But I'm not talking about processes as far as, click here, click here, click here. What I'm talking about is the way that you do things. If you implement certain security procedures in one cloud environment, you should try to mimic that as closely as possible in any other cloud environments that you might use. Sure, there might be some variations that you have to make from one cloud to the next, but you should try to keep things as consistent as you possibly can, because that's going to make it much easier to detect security incidents. And the reason why I say that is it goes back to casino security of all things. In Las Vegas casinos, and probably in most other casinos as well, the dealers at the table games are taught to deal games in a very, very uniform way. I'm sure you've seen in the movies or maybe even incidents in real life where somebody will move their thumb the wrong way in a card game and the next thing you know, security's all over them. Well, the reason why it's possible for that to happen is because the games are dealt in such a uniform way. So that way, anything abnormal at all stands out. Well, that's the same type of thing that you should seek to do with regard to your hybrid cloud environments. If you maintain those environments with regard to security and with just normal day-to-day operating procedures, if you maintain those environments in a super consistent way, then it makes it a lot easier to spot anything that is out of the ordinary that might signal a security incident. Another thing that I'll kind of throw out there is that casino security also practices something that they call JDLR. And JDLR stands for just doesn't look right. Because sometimes in casinos, there may be something going on and security can't quite put their finger on what's happening, but it just doesn't look right. So they go ahead and question the person that's involved in that particular incident. And sometimes it ends up being something totally innocent, but sometimes it's the exact opposite. The point being that it's really hard to pick up on those JDLR type incidents if you're not doing things in a really uniform manner. So strive for consistency in your hybrid cloud environment as one of the most important security best practices. Another best practice, and this goes back to another one I was talking about earlier, is to assess risks and manage treatment. As I said earlier, in a perfect world, security budgets are infinite, but in the real world, we all have budgetary constraints with regard to our security. So it's really important to spend that security budget where it really matters. So the way that I would recommend getting started with that is to, A, identify your most critical workloads, because if you've got something that's super mission critical, then that's probably where you want to focus your security efforts. And then B, identify your biggest potential vulnerabilities. This could be some new attack vector that's recently come out. It might be something that was set up on your network years and years ago and just really needs to be overhauled and done in a different way. Whatever it is, it's important to identify your your biggest potential and vulnerabilities. Now, on the flip side of that, one of the ways that you can get around these budgetary constraints is to look for low budget or even no budget things that you can do to improve security. Now, given what IT security products cost, that sounds ridiculous, but there are probably some things that you can do in your environment right now that could help with your security efforts while spending very little, if any, money at all. For example, one of the first things that I recommend that people do is take a look at their Active Directory groups and make sure that the group memberships are still appropriate. Because in any organization, what happens a lot of times is that over time, people will be added to various groups and then they end up changing job roles. But a lot of times those group memberships don't change along with the job role. So people will end up with access to things that they used in their previous role and no longer need access to, and yet that permission doesn't go away. And the same thing can happen with privileged accounts as well. So it may be worth your while to just take some time, go through your Active Directory groups, and make sure that the memberships associated with those groups are still appropriate, and make sure that access control lists that reference those groups are also what they need to be. Another best practice is to encrypt absolutely everything in your hybrid cloud environment. There was a time when this best practice didn't exist, and that's another example of radically changing best practices. Because in the early days of the cloud, one thing that was often referred to as a part of conventional wisdom was that there's a bit of overhead that has to occur with regard to the encryption process. When you encrypt something, it consumes some memory, it consumes CPU resources. And so there was a time when the guidance was encrypt only your most sensitive information because you don't want to subject your CPUs to too much of a load. And that obviously isn't the case today. We all have plenty of CPU resources. So as a best practice, I would recommend encrypting everything. Now, the big caveat to that is that if you are going to encrypt everything, make sure that you protect your encryption keys to the extreme, because key loss is the same as data loss. I was reading about something just recently where a human-operated ransomware gang was going after this particular organization's backups, but rather than attacking the backups themselves, because the backups had been pretty well hardened, all they did was attack the encryption key associated with the backups. Because if that encryption key is gone, then the backups remain encrypted and they're completely unusable. And I'm just using backups as an example. This applies to any type of encrypted data. So encryption is great, but make sure that you preserve a copy of those encryption keys offline in an air-gap backup that you put in a really safe place and can restore on an as-needed basis. Now, this presentation was supposed to be about hybrid cloud backup and recovery and security. And so far, I've focused almost entirely on security. So let's shift gears a little bit and talk about some best practices with regard to cloud backups. And there are so many of these. I could probably do multiple sessions just on cloud backup best practices. But here at the end, while we've got a few minutes left, I want to throw out a few of the more important ones. Starting with, be aware of the potential cost and bandwidth constraints associated with backing up to the cloud. What do I mean by this? Well, any type of backup that you create is going to incur cost, whether that backup is on premises, in the cloud, or whatever, because you're going to have to store that backup somewhere, and that storage costs a certain amount of money. You know, if it's on premises, then you might be writing to a tape or to a hard disk, and there's not really ongoing costs associated with that. But if you're backing up to the cloud, then of course you've got a per gigabyte per month storage fee, and you've got bandwidth fees associated with getting the data up there. But whatever those costs are, just be aware of them and be aware of any bandwidth constraints. The next best practice, use data deduplication where it makes sense to do so. There was a time when I actually recommended against data deduplication, just because from a data recovery standpoint, it's a lot easier, or I guess, what's the word I'm looking for? I guess it increased your chances of being able to recover your data if need be, if that data hadn't been manipulated in various ways, such as deduplicating it. But data deduplication has actually been around a really, really long time now. I remember giving talks on it back in 2012. So I would say that by now, data deduplication has had plenty of time to mature as a technology, and it's as reliable as anything else out there. So I certainly wouldn't hesitate to use deduplication. And the reason for using deduplication is if you're doing deduplication at the storage level, it can greatly reduce your costs, particularly in a cloud environment. But also, if you've got on-premises data that you're trying to back up to the cloud, using data deduplication can shrink that data before it gets uploaded, so that way you're uploading less data and you can get that data up there more quickly. So this is really, really helpful in a limited bandwidth environment. The third best practice on the list is don't fall into the trap of relying solely on cloud backup. Cloud backup has its place, absolutely, but don't use exclusively cloud backup if, just because it's in the cloud and it seems like what everybody else is doing. There are still use cases for backing up on premises. Let's see, the next one is don't underestimate data egress fees. Now, not every cloud provider charges data egress fees. I can think of at least one cloud provider that offers S3 compatible storage and they don't charge data egress fees, but all of the big providers do. If you're not familiar with the data egress fee, what it is it's a fee that the provider charges you for sending data out of their cloud. So in other words, if you've got an on-premises workload and you back that workload up to a public cloud, and then one day you need to restore that data, you're going to have to do a restoration from the cloud. And in doing that, you're going to incur data egress fees because you're removing data from the cloud. Even if that data actually stays in the cloud, you're making a copy of it and sending that data out of the cloud, so you're incurring those fees. And depending on how much data you're dealing with, those fees can be quite substantial. So it's important to take a look at what your cloud provider is charging for data egress fees right now so that you have an idea of what it might potentially cost to restore a backup should the need ever come about. Then the next best practice is replicate data to other regions, if appropriate. So one way that you can protect your data is to back it up to the cloud and then replicate that backup to other regions. So that way, if there were a regional level disaster, such as a huge flood that takes out an entire region or a nuclear attack or some other catastrophe, and it happens to wipe out your cloud provider's data center, you've got a replicated copy of your backup in some other data center in some other part of the world. And again, there are costs associated with doing that, but those costs may very well be justified if you want to have a secondary copy of your backups available. Because remember, back in the day, we had something called the 3-2-1 rule with regard to backups. And the idea behind the 3-2-1 rule is that the only way to really make sure that your data is safe is to have 3 copies of the data that's the original and 2 backups. And those backups should exist on 2 different types of media with 1 copy of that media being off-site. Now, the 3-2-1 rule doesn't really translate all that well to modern times with the cloud, but the basic idea behind the 3-2-1 rule is that you need to have multiple copies of your backups in different locations. And using those various cloud regions is one way of accomplishing that. And then the last one on the list is make a concerted effort to seek out any single points of failure. Because remember, your backup is your last line of defense. It's what you fall back on if bad things happen and you've got no other way to recover. So it's really, really important to make sure that you don't have any kind of single points of failure in place that could cause that recovery to fail. And in some ways, this aligns with backup testing, but it actually goes a little further than that because you're taking a detailed look at your entire backup and recovery infrastructure and just making sure that there are always going to be multiple paths for getting your data back. And then just a few other quick backup best practices. I know we're just about out of time here. Use an extensible backup solution that works with everything. This goes back to what I was talking about earlier with regard to, is it better to use a combination of best-of-breed products, or is it better to use one single monolithic product that can take care of everything? Again, in my opinion, with regard to backups, it's better to use a single product that can back up your entire environment. You just need to make sure that that product can provide the granularity you need. For example, you should be able to restore a database. You should be able to restore a virtual machine. But you should also be able to restore the contents of that virtual machine, whether that be files, folders, applications, or what have you. And it's also important to make sure that that backup solution supports workload portability, since workloads do tend to move around a lot. And a really good example of this is what we had back in the early days of server virtualization. Because back then, what would happen oftentimes is that organizations were using backup products that were designed for use in physical server environments, and they were trying to make them work in virtual server environments. And for the most part, that worked no problem, with a few little hiccups along the way. But one of the big issues that organizations ran into is that they would live migrate a virtual machine off of one host onto another, and the backup product that they were using didn't know anything about that. So when that virtual machine landed on the secondary host, the backup wasn't configured to back that virtual machine up. So now, of course, most backup products that are designed for virtualization just back up everything on the host. They don't have to be pre-programmed to recognize specific virtual machines like what we had way back when. And that's the same type of thing that you need to have with regard to cloud environments, is that your workloads need to be protected regardless where they've moved around within your hybrid cloud infrastructure. And then finally, what I was saying earlier, be sure that you're taking steps to secure your backups and to protect them against ransomware, because ransomware very often will attack backups. One of the big recommendations that I make is write backups to immutable storage if at all possible. That's not always going to be an option because there can be significant costs associated with doing that, but immutable storage will oftentimes give you a really good way of being able to recover from a ransomware attack. I'm also a big fan of air-gapped backups. Air-gapped backups are backups that are created and then detached from the system because ransomware can't attack a backup that's not mounted at the moment. So I use this in my own environment. Air-gapped backups have a really high recovery point objective, so they tend not to be as current as your online backups. But what I do is I use a continuous data protection solution to protect my resources in real time. But every couple of days, I'll make an air-gapped backup that I can simply remove from the system so that way, if my backup environment happens to get attacked, then maybe I can't restore everything, but I can restore the vast majority of it. So with that said, I know we're just about out of time, so I would like to go ahead and open it up for questions.
Okay, great job. I'd like to remind the audience that we can take questions up until about 5 minutes to the top of the hour in order to give you a short break before the next session. So please send them on in now. And let's get right to the Q&A box. First question. Okay, Brian, you mentioned the just doesn't look right concept, or JDLR, used in casino security. Can you expand more about that as it pertains to IT security?
Sure. The idea being that you know your network better than anybody. There are certain things that are going to be unique to your network that nobody else has. And the same thing applies to my own network. There are things that are unique to it that are going to be different from every other network in the world. So because you have that intimate knowledge of your network, there's a good chance that you're going to pick up on things that maybe a security professional who is doing an assessment of your network might totally miss. So if there's something that just seems abnormal for your network, then that's something that's worth paying attention to, because it might signal that there's some kind of security incident that's happened.
Okay, next question. Why does some ransomware attack backups?
Well, the idea is that ransomware, as it was originally created, was designed to encrypt all of your data and then charge a ransom, and that at payment of that ransom, you would get a decryption key that would allow you to decrypt your data and return things to normal. And the ransomware authors know that if you're able to restore a backup, then they're not going to get paid because you're not going to need their decryption key. So ransomware authors very often will try to keep that from happening because they want to get paid. So they try to attack your backup and completely take that out of commission so that you have no choice but to pay the ransom if you want your data back.
Okay, here's a question about those really low-cost things that you can do to improve overall security. I know you went through a number of them. But here's a question asking about some more, or can you point to a resource where somebody might find more of those low-cost, no-cost security measures?
Yeah, I can't really think of a specific resource out there, but there are a million things like that you can do. Even something like going over access control list or reviewing your network configuration, or even just taking a look at your routers and any hardware appliances that you've got applied and make sure that they're not using default passwords or default administrator account names or things like that. Those are all things that you can do that cost almost nothing, and yet if you find something, they can make a big difference on your security.
Okay, great. Next question reads, how do we justify the cost of more copies and versions while our budgets are shrinking and our data is growing?
Yeah, that is a really, really tough one. The biggest thing that I would point to is recent events that have happened. If you've got somebody in management that is wanting to constantly shrink your budget, and yet you know that there are things that need to be done security-wise, point to other organizations, maybe even in the same industry that you're in, that have recently been attacked and what that attack ultimately cost them. Not necessarily the cost of a ransom if it's a ransomware attack, but all of the cleanup that had to occur afterwards, lost business, trying to think here, maybe even things like data protection insurance that had to be given to your customers as a result of the attack. But then again, if you happen to work in a regulated industry, then it's not even a question because there are laws in place that dictate what you have to do with regard to keeping that data safe. So your manager's hands are kind of tied at that point. They more or less have to give you the budget that you need to adhere to the regulations.
Okay, great. Okay, we have time for one more question. This comes from Terry in the audience. He says, my backups are segmented by a firewall and have a separate two-factor login. Would that be safe from ransomware?
It could be. There are types of attacks that I probably don't have time to get into the logistics of this, but there are types of attacks out there where a human-operated ransomware gang will attack the data, and they'll make it so that it's not super obvious. And what happens is that you've been backing up, I don't want to use the word corrupted, but maybe infected data for a period of months. And what their goal is at that point is to outlive your backup window and make it so that you don't realize that there's a problem until after all of the backups that predate that problem have already been overwritten. So I would say that what you're doing with your backup right now is a really, really good start. It's probably better than the vast majority of them out there, but I wouldn't consider it to be 100% secure simply because there are so many different attack vectors against backups.
Okay, it looks like that's all the questions we have time for. So thanks again, Brian, for an excellent presentation and answering all those questions.
Thanks for having me, David.